Let's now talk about the physical properties of alcohols, starting with solubility. Low molecular weight alcohols are soluble in water in all proportions. What we often observe is that alcohols that have four or less carbon atoms are very soluble in water. The minute that the number of carbons increase to five, six, seven carbon atoms for an alcohol, we can see that the solubility of those compounds is going to be decreasing to the point that they're not soluble in water. The main reason why alcohols of 1 to 4 carbons are very soluble in water is because of the strongest attractive force, meaning hydrogen bonding. Alcohols of 1 to 4 carbon atoms can hydrogen bond to water. When we look more closely at figure 9.9, what we observe specifically, here we have the hydrogen bonding events that are going to be occurring specifically between a molecule of methanol, which is this. We see one carbon atom holding the OH. This is called methanol. And methanol is very soluble in water because we can observe that specifically this molecule, the oxygen in the alcohol, can act as a H bond acceptor, and the dotted line that we observe here represents the hydrogen bond between specifically the oxygen in the alcohol to the hydrogen atom in the water. Now, we can observe on the other side that the hydrogen bonding event can also occur between the oxygen in the water and the hydrogen in this alcohol. Because one of the special features for alcohols is that we have in the functional group a covalently bond hydrogen to an oxygen atom. So we can see that alcohols can also be H bond donors. So, because of the ability of the different hydrogen bonding events that we can see between alcohols of 1 to 4 carbons in water, that's why they are very soluble in water. Let's now proceed to talk about reactions of alcohols, starting with acid-base reactions. Alcohols are neither strong acids or strong bases. Okay? They have their own behavior when it comes to acid-base reactions. And to be honest with you, the behavior of an acid-base reaction with alcohols depends upon whether the species are in solution and how the alcohol is going to behave. Alcohols are best described as amphoteric molecules, meaning depending to which compound they're exposed to, they can either act as a base or they can act as an acid. That's what amphoteric means. So, for example, if we have an alcohol that is in the presence of a strong acid, so we see the reaction in the bottom, meaning R is going to be, remember, the rest of molecule, meaning carbon chain. If we react that with a strong acid, so if we have a strong acid, that means that X must be chlorine, bromine, or iodine. When we look at the reaction in this instance, what we see specifically is that the alcohol is going to be acting as a base. Since we're reacting it with a strong acid, then the strong acid will be acting as an acid. And what we observe is that since the alcohol is acting as a base, it will accept a proton. And what happens overall is that the oxygen atom in the alcohol will get bonded to the incoming hydrogen and now is going to have an overall formal charge of +1. In turn, because the strong acid gave away the proton, is going to form specifically an anion. So it doesn't matter if it's chloride, bromide, or iodide, that's why we see an X minus. This reaction specifically is reversible. And we know that it is reversible because we can see the arrows pointing in the forward direction, which is this one, and also in the reverse direction. We can see it here. Now, I just mentioned that alcohols are amphoteric, and we observe how they behave as a base. If an alcohol is in the presence of a base, and it could be strong, and depending on the alcohol, we're going to see in a moment how phenol behaves in water. Overall, what we observe is that if an alcohol is in the presence of a base, that it is specifically able to take this hydrogen away, then the alcohol will behave as an acid. And since we are reacting it with the base, bases are going to take away specifically the hydrogen in the alcohol, and then we see the base that is protonated. Since the alcohol will lose a hydrogen, then the oxygen is going to gain a -1 formal charge. To illustrate an example of specifically alcohols behaving in this way, we have phenol as an example. Phenol is actually a special alcohol because specifically is going to behave as a weak acid. And even in the presence of water, when phenol is exposed to water, one of the things that is observed is that phenol will be acting as a weak acid. Water in this case is going to be behaving as a base. And when water accepts a proton, it makes the hydronium ion. Since phenol now is going to be lacking that hydrogen, it makes what is called the phenoxide ion. And we see that this phenoxide ion has an oxygen atom that is -1 charged. So a phenol can do this with water, or it can do this with any strong base. So in the example below, we see phenol reacting with potassium hydroxide. And in this case, that OH in potassium hydroxide, because remember that this is an ionic compound that is able to ionize in water. So ideally, the way that we visualize this as K plus and OH -1. And what happens overall is that this OH -1 will take away this hydrogen, and that's where the water comes from. So this take this hydrogen, and that's how water is formed. Since the oxygen in the phenol is going to now not have the hydrogen, it gains a -1 charge. And in order to be stabilized, since we have an available cation, we see it sitting next to the -1 in the phenoxide ion. Let's look at the following examples for reactions of alcohols. In letter A, we have an alcohol reacting with a strong acid. We learn all the way back in chapter 7 which ones are the strong acids. So please, if you don't remember which ones are the strong acids, review that material. When an alcohol is exposed to a strong acid, then what we observe is that the alcohol is going to behave as a base, the strong acid is going to behave as an acid. The product of this reaction, even if it's reversible, is that now we are going to have an oxygen atom that is covalently bound also to a hydrogen, and then the oxygen is going to become +1 formal charge. This is also going to be in the presence of Cl-, which essentially is the conjugate base of HCl. In example B, we have an alcohol that is behaving with specifically a base. This is a new type of base. This base is when we have a carbon atom negatively charged. So if I write the condensed structure for that base, this is going to be CH2, CH2, CH3. And basically, essentially, what this is illustrating is that this CH2 has a lone pair of electrons. That's why it's negatively charged. So whenever we see something pair that is negatively charged with somebody from 1A or 2A, please let's assume that that is going to be a strong base. When an alcohol is exposed to a strong base, what's going to happen is that the alcohol is going to lose a hydrogen. And what happens in this molecule is that when the alcohol loses the hydrogen and we draw the molecule, now the oxygen is going to be negative charged. In turn, this molecule is going to produce propane, because if I write the condensed structure for it, what we observe is that corner CH2 is now bonded to a hydrogen. And that hydrogen was the one that used to be bonded to the oxygen. That's what this hydrogen here is. The lithium is going to sit next to the oxygen that is negatively charged. So we will write Li plus, and let me circle the plus next to the O minus to balance the charges. Another reaction that an alcohol can do is combustion. When it comes to the combustion of an alcohol, let's understand that in the combustion of an alcohol, the product is going to be the same as combustion of any hydrocarbon. When alcohols combust, the product of the reaction is going to be CO2, water, and energy. That means that any compound that has carbon, hydrogen, and oxygen, and it is an alcohol, it doesn't matter if it's a straight chain or if it's cyclic. When you combine it with O2, and remember that heat is part of the system, so you need to input heat. We're going to produce CO2, water, and energy. Whenever you go to a restaurant and they prepare a flaming dessert, that's an example of a combustion of an alcohol. Pretty much what it is igniting, the flame that you observe right here, is the alcohol that is being combusted, and the flame is specifically the energy that is generated upon combustion of the alcohol.